I don't even know if there's such thing as a snowplow graveyard. We see trucks that are 20, 30 years old. So these trucks are being used forever.
Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lenke, and it's my job to interview interesting people who are moving fluid power technology forward. If you'd like to be part of our show, as always, we ask you to follow us on Twitter. You can find us there at the NFPA. And make sure to share interesting and innovative uses of fluid power on your social media of choice with that hashtag #OnlyFluidPowerCan. That is actually one of the ways that we sourced topics for our show. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also ask that you subscribe to our show. You can find us on Apple Podcasts, on Spotify, on a lot of the other popular podcatching services. Wherever you find us, please subscribe and then give us a quick rating. That really does help more and more of our friends in the industry hear about the show and join in on these important conversations. On today's show, our guest is Jeremy Flasch. Jeremy is a product manager in the electrical division at Force America. And Force America is an employee-owned manufacturer, distributor, and integrator that provides systems and components to the on- and off-highway mobile markets. We invited Jeremy into our forum today because we want to learn more about a unique electronically controlled application of hydraulics, the precise dispersal and spreading of snow melt from on-highway trucks. So Jeremy, welcome to Fluid Power Forum.
Yeah, thanks, Eric. Thanks for having me.
We're glad to have you on the show today. I'm looking forward to learning more about this unique application of fluid power. But before we go there, hopefully you can tell our listeners a little bit more about yourself. How did you find your way to Force America?
Yeah, so my background is actually computer engineering. So I started at Force America right out of college. I have a computer engineering degree from Milwaukee School of Engineering. So probably not something you deal with on an everyday basis in the fluid power side of things. But I've been here almost 14 years now. So
Right.
I started off in more of a product support role and got to really know our customers very well, got to know our sales force very well. And with all that, I got to really know people across the whole company. And over the years then, that really set me up really well to do more of a product management type role here. So
Sure.
For the last 9 years, that's kind of where I've been. And I still get to interact with our customers. I still get to support our products, but I also get to make some more of the decisions now and understand what our customers need and work with the teams here to make that happen.
That's great. Yeah, you mentioned computer engineering is not necessarily a track that leads direct into the fluid power industry, although more and more, and the application that we're going to talk about certainly is a nice marriage between computers and fluid power system. I'm curious, MSOE is a great fluid power school. Did you get exposed to fluid power at all while you were there at MSOE, or when did you first come across fluid power then?
No, actually, I didn't. Any of my fluid power knowledge is really just from on the job here.
Right.
I like to say I know enough to be dangerous. Not dangerous as in dangerous, but I've learned a lot over the years. I know how our controllers interact with the hydraulics, and if I don't know the answer, again, I know who to bring into the call or bring into the meeting to help me through those issues here from somebody else at Force America.
Right. Well, I'm sure there's a team that, you need the fluid power knowledge and the computer knowledge both to execute the kind of products and systems that you guys are designing there. So it's great to have you in the industry, and I'm sure you're not you won't be the only one with that kind of background as we continue to grow and develop.
Yep.
So tell us a little bit about Force America. I don't know, that's a company that has a national reputation, if you will. So how would you describe them as a company?
Force America, we provide systems and controls to a wide variety of customers. Ag, refuse, forestry, mining, or what I'm most close to is the snow and ice side of it.
Mm-hmm.
Basically anything hydraulic on a mobile piece of equipment, that's what Force America does. That's what Force America provides solutions for. So we're a distributor, pumps, motors, cylinders, and we stock a lot of inventory throughout our different locations.
Mm-hmm.
And we've also got our manufacturing divisions. So we've got Veritech. They're our liquids solutions. Basically, they're treating the roads before an event. They're the masters of salt brine.
Right.
Heartland Hose, we can provide a whole kit of hoses, cut to length with fittings already crimped on the ends of them, and even labeled with what that hydraulic function is for that particular machine. We've got Precise MRM. They're our telematics side of the business. So there's more and more going on these days with cellular and GPS. We've got our valve division. We've got 11 CNC machines there going on to 12. And we mill all of our products in-house. And then, of course, where I'm out of is the electrical side. So on the electrical side of our business, we are focusing on spreader controls, joystick controls, the snow and ice. Force America, I would say we are, what I'm most proud about is we're a very customer-centric company. We're here every day for the customer. That's why we have all the different manufacturing divisions. That's why we stock the inventory that we do, because our main goal at the end of the day is to make sure we're taking care of the customer.
Yeah, well, I was going to say that that was a great description of all the different pieces of your puzzle, and it just is a testament to the different expertises and product qualities that you can bring to a customer. They increasingly need not just one thing. They need a whole bevy of support and products, as you just described. So it's wonderful. I mentioned in the opening that Force America is employee owned. What exactly does that mean, and why is that a good thing?
Yeah, employee owned. It's probably a little something different to everybody. And actually, we have a culture video on our website, and it interviews a few different people in the company and gives their thoughts on it. To me, employee ownership, I would say it's the culture. We wear a lot of different hats. You'll never hear somebody at Force America say, that's somebody else's job. That's not my responsibility. We all take that extra step to help solve a problem. I'll give an example of that. I mean, and this happens all the time, especially this time of year. It's that type of season for the snow and ice side. Yeah. There's oftentimes we'll take a phone call at 4:45, 5 o'clock, end of the day, asking for a part to be shipped out. And you'll always find a volunteer to go. UPS has come and gone already. You'll always find a volunteer to go take that and drop that part off at UPS for the customer.
That's great.
That to me that's the culture. That's the employee ownership.
Because you guys are all owners of the company. It's all your company in a way, right? You have that kind of sense of ownership over it, real and culturally speaking, as you described.
Yep.
So as I said, we want to talk about just one of the many different applications that I know you work on there at Force America, and that is the control system, if you will, that spreads snow melt, and I think that's a generic term for a lot of different kinds of products, right? Off the back of on-highway trucks. So maybe we can ground our listeners first in the vehicle itself. Like, what kind of trucks are we talking about that this application go on?
Yeah, we're really talking about any truck with a central hydraulic system. So it might start as something like a Ford F550. They are likely going to have one of our more entry-level spreader controls. But, I've seen some of these Ford F550s with some of our flagship products in there too. It's kind of funny. My first time ever in one, I was the guy who was showing it to me. I asked him, I said, "Is this a supervisor's truck?" Because this truck was it was something I would want to drive. It had a backup camera, and that was really before backup cameras were really a thing. It looked comfortable. It looked like, again, something I'd want to drive. And he said, no, it's actually the new guy's truck. What I learned is that, the F550s, they're easier to drive, easier to get into smaller spaces, back alleyways, things like that.
I'm a slave to my backup camera, so I can only imagine, especially for an application like this, it must be great. You can actually probably see the spreader with the backup camera, I'm going to imagine.
Yeah. It was, like I said, it just felt comfortable. I sat in the passenger seat, and it felt like anybody could really drive it. Right. Whereas the bigger trucks, and that's where we really probably spend more of our time, the bigger Max, Internationals, Freightliners, Navistar, the larger size trucks that have 2, 3, 4 axles on them, those things are obviously a lot more difficult to drive. There's a lot going on. Yep. And that's where we really, the central hydraulic systems where we see them the most. And all these trucks, really, they start with a plow and a dump box, and then they kind of go on from there. I mean, you can have a wing plow coming off the side. You can have a wing plow coming off of both sides. Yeah. I recently just saw a truck that was actually 4 axles. It had the plow, the dump box, and it had a wing off of both sides.
Oh my.
And if that wasn't large enough and long enough, because it was such a long truck. It was also towing a trailer, and this is a newer thing that we're seeing is tow plows. So this tow plow was another 30, 40 feet long behind the truck, and what it does is it'll swing sideways to cover an extra lane while driving down the road.
So there's a lot of variation, it sounds like, in terms of the different trucks. I mean, in my hometown, I most often see it's the garbage trucks that get repurposed in the wintertime for plowing and for dropping either salt or something else on the roads to take care of the snow and the ice. Are you designing unique products for each of those different trucks, or is there like a modular approach to that? How are you doing that?
Yeah, Forest America certainly does work with some of the garbage truck OEMs out there. Mm-hmm. But I can't really speak to, how the plow gets added. I don't know if it's something from the OEM or if it's something that maybe a municipality adds on later as an accessory. But what I can say is that snowplows they're very expensive vehicles, and they're really only used a few months of the year. Right. So what we see is, for budget purposes, we see these vehicles being multi-purposed for other things. In the summertime, we'll see them spread gravel for on the sides of the roads. We'll see them used for asphalt. These municipalities need to turn them into an asset in the off season as well. In Minnesota, these trucks, they'll use them in the summertime to help protect road crews. They've got this, it's called a collision attenuator, and mm-hmm. It's behind the plow truck. It looks like this really oversized bumper, and again, it's just it's a collision thing to help protect the people working on the road. I've even seen them used as these plow trucks used as roadblocks too. My wife actually, she's a runner, and she did the Chicago Marathon one year, mm-hmm. and I was down there for it. And every intersection along the routeway had one or two of the city of Chicago plow trucks used to block the intersection. So yeah, garbage trucks used, repurposed in the wintertime, and these plow trucks are repurposed in the summertime too.
Yeah. I don't know that I can't think of what the hydraulic application would be for a roadblock, just a big hunk of metal sitting there, I'm assuming, right? So
Yep.
But in a pinch, right, it'll work. So again, we're talking about an electronically controlled, hydraulically actuated system that spreads snow melt off the back of these trucks that you've just described in all kinds of different configurations. I wonder if you can speak first about some of the challenges that are associated with that. I mean, there must be environmental concerns, knowing that these trucks operate in really, really cold weather sometimes, right?
Yeah, you hit it right on the head there. These trucks see some extreme conditions, and downtime really isn't an option for them.
Right.
So we've got to make sure we do a ton of testing. Extreme cold, you said that one. We basically, when we design a circuit board, we make sure that every single component that we pick for that board is rated from negative 40 degrees Celsius to 85 degrees Celsius, which is basically negative 40 to 185 Fahrenheit. So that's the step number one, is just to pick the right components. And then after that, again, it's a ton of testing. So with the temperatures, we do thermal shock. Thermal shock basically takes, you put it into a chamber, and it'll go from the really high temperatures to the really low temperatures and do it rather quickly to really just stress the product. And one thing we found with that, in some of our initial design phases, we use potting compound for modules that are mounted outside the cab that really need to be sealed. We saw during this thermal shock testing, the potting compound actually expand and it basically start cracking down the middle of it. So that's something we changed. We picked as part of this testing, we picked a softer potting compound, something that was a little bit more pliable, and it was better for our conditions. Also, these plow trucks, there's vibration. I mean, that's a huge thing. So we pick connectors that are rated for higher vibration, and then we go to lab too. We use a 3-axis vibration table to really simulate what the product might experience over the lifetime of it. Same thing there. We always find something in this testing. We had a component on a circuit board. It's called a PTC. It's a resettable fuse, and it's a little bit bigger of a component. And through this vibration, it literally sheared off the circuit board.
Oh my!
So we had to find a better way to protect that down the road. And then also with that testing too, we can simulate impulse change in direction, which is almost like maybe not as is necessary for these types of things. It's more meant for, say, you drop a product off the shelf, so maybe more meant for consumer goods. But in this case, it's still, if you driver jumps in the cab and accidentally kicks it or something along those lines, that's what we test for.
Yeah.
And there's a lot more too. We test for moisture, for IP ratings are a really big thing. IP68 is a big standard in our industry. That's a term you'll hear. And what that really means is that the connector or the product can withstand dust, dirt, sand, and basically be submerged for up to 30 minutes at a certain depth. And we actually go one step above that too. We go to IP69K. That's the standard that a lot of our stuff is rated for. And same thing there. We do the testing behind it. And when we first launched our flagship product, which is really that highest rated product of ours, we took it to a trade show and we put the module inside of a fish tank. No fishies harmed in the presentation of it, but it just showed that our product can really hold up to that kind of stuff.
I just find that fascinating, Jeremy. I've talked with other guests on the show, and the range of environments that fluid power systems have to operate in and do so reliably and as you're describing, it's just a remarkable testament to the ruggedness of this technology. The testing is absolutely required, as you're describing. You can't just throw something together. You got to plan for all that. But once you do all of that, you can have something, as you said, you can't afford to have these trucks not be working when the snow is flying, right? So that's a great overview of all the different thought processes that have to go into designing the system.
Exactly, and that's just the tip of the iceberg. Yeah. There's so much more testing beyond that. That's just the tip of it.
I'm curious, how, if I can ask the question this way, how new is this kind of application? Is this been in the marketplace for a while, or have these things always been hydraulically driven, or were there older ways of doing this before that?
Yeah, for my career, this is mostly it's been a lot of electric spreader controls. Before that, what I've heard of, I haven't really seen too much of myself, but heard a lot of it is there's a lot of cable and air controls, and we still see those today. Don't get me wrong there, but even more beyond that, what we used to see sometimes was the valve actually in the cab of the plow truck, and when the valve is in the cab, basically there's a couple knobs on there. The operator would just manually adjust these knobs. And if you can imagine that, you don't really have the precision. And then on top of that, what happens if a hydraulic hose fails? You got hydraulic oil all over the cab of the truck. It's a safety factor for the driver. So that's my understanding of how things kind of used to be.
Yeah, and so there's a lot of advantages to this newer solution, if you will, as you're describing, that just being one of them. I can't even find a radio station while I'm driving at the same time. So I can only imagine, forget about the snow flying all around you in the snowstorm. So yeah, all right. Well, we're going to take a quick break here. When we get back, I want to ask Jeremy a lot more about the hydraulic system and, more importantly, the electronic controls that he's designed to make it work. But let's take a quick break here and provide our listeners with an update on some other opportunities in the fluid power industry. All right, we're back with Jeremy Flasch of Force America, and we're talking about electronically controlled, hydraulically actuated automatic spreader systems that are used for dropping snowmelt on icy roads throughout the winter. I guess in the northern part of our listening area, right? A lot of the industry is down south and maybe aren't familiar with these kinds of applications. So Jeremy, we were just about to dive in a little bit more to the system itself and how it works. I know you're not a hydraulics expert, but maybe you can give us a quick description of the hydraulics part of it first. What is the system, and how does it? What components do you need in order to make it work?
Yeah, again, we're really talking about a central hydraulic system. So a reservoir of oil, a pump, a valve stack, and then we use cylinders and motors to really drive the functions of the truck, to raise and lower the plow on the front of it, to raise and lower the dump bed, the wing plow off the side of it. That's what we're really doing here. And really, there's two types of trucks. They all have the plow, they all have the dump box, but it really comes down to the spreader. So at the back of the truck, there's two different types of trucks. We've got a V-box spreader, we call it. And what this is, it's a unit that slides into the back of the dump box. It's shaped like a V. The salt really falls down onto a conveyor, and that conveyor pushes this material towards the back of the truck. These are usually a little bit more precise. They also can really get that last drop of salt, if you will, out of the back. But the other version is more of a tailgate spreader. So what that means is that there's a trough at the back of the truck, and it's got an auger in there, just like you would. An auger, it turns and it really pushes the spinner off the side. And then at the end of the day, this all falls onto a spinner disc, which then spreads it across the road. So those are the types of trucks that we're really talking about here on the snow and ice side.
And this rotary motion, whether it's the conveyor or whether it's the auger, is that a rotary actuator that's doing that?
So that's usually hydraulic. That is a hydraulic motor,
Yep.
And that's actually what we're really controlling with these electronics. We're speeding up and we're slowing down that motor to make sure we put a precise amount of material down on the road.
So that's the nice segue into the electronic control system then that detects and then decides. I always hesitate to use that word because I don't know that there's real intelligence going on in the system. It's more reaction, if you know what I mean. So. But talk to us about that. Describe how that system works, how it knows how much material to put down when.
Yeah. So when we're kind of really designing these things, the first thing we're doing is we're thinking about safety. So we want to make sure that everything's safe. We've got e-stops on the side of it, and you said they're not really. You think about maybe not necessarily intelligent, but there's a lot of software that goes into all this stuff. So we're monitoring different things along the way. We've got come back to the actual snow ice application, the sand and salt application next, but let's start off with just the joystick controls. We're really looking to make sure that we're monitoring some signals on those joysticks, and we use, actually, this is most important, I think, in our application. We use redundant outputs on those joysticks. We want to make sure that that the wing plow doesn't come down when there's a car on the side of the plow truck. And we can monitor these outputs and put a lot of sophistication into how those, we don't run that function unless it was absolutely intended. We do a lot of this through CAN bus. So all of our screen, our modules, our outputs, everything's tied together through a CAN bus, and that really helps to clean up the system. At the end of the day, though, what it really comes down to, again, it's that software. So that software is a really well-designed, thought-out control loop. The operator will actually set a rate on the controller, and it'll set it at, say, 200 pounds per lane mile. And if you think about it, think about a 50-pound bag of salt. It's actually not a lot of salt. And if we're putting down 200 pounds of salt in the course of a mile, it's definitely not a lot of salt. So this is some pretty precise application of material. So the spreader control will actually monitor the speed of the truck, and it'll actually watch a sensor on that auger motor that we were just talking about at the back of the truck there. And then it'll make all these different calculations behind the scenes. It knows that when that shaft turns, that auger turns one full revolution, and knows exactly how many pounds of salt were put out. And what it does is it takes the pulses coming from that sensor and can then make decisions. So we will, again, speed up or slow down that auger motor to maintain that exact 200 pounds per lane mile, even as the truck is speeding up and slowing down.
Wow. Well, I'm curious, what's the resolution on those sensors? Are they taking a data point every second or more frequently than that? How often does that happen?
Our control loops really run on 100 milliseconds. So 10 times a second, we're actually running through the whole gamut of calculations. That feedback sensor is always running, but 10 times a second, we're going through there. We're making little adjustments. We're checking the latest ground speed from the truck. We're just going through the whole list of things. Any feature that's enabled, we're making sure to do those types of things and adjust in the process.
And so you said at the beginning that the operator in the cab sets it for a certain dispersal rate, if that's the right way to say it, right? And then the adaptive controls and the sensors kind of take over from there to ensure that happens. Is there feedback coming back to the operator in the cab then for the actual conditions of what's going on?
Yeah, certainly. So a lot of it comes up on a display. And I've done a lot of ride-alongs with operators over my career. And when a driver is driving down the road, I think we said it before, there's a lot to think about. Their main focus is keep their eye on the road. So a lot of this is done by touch. So they'll set that set rate to say 200 pounds per lane mile, like we discussed, and then they'll leave it. They'll set it and forget it. What they really do is they'll keep their hand on the plow joystick most of the time. They're feathering that plow, raising it, lowering it, angling it, because they're pushing snow. they'll be going in and out of standby. Say they come across a section that they're not supposed to be spreading, they'll turn off the salter for a second.
Mm-hmm.
Or if they're going through intersections, they'll hit the blast button. So you want a lot of material put out really quickly so those intersections are safe. When people come to a stoplight, they don't slide through it. So that's what they're really focusing on in the cab. And going back to that safety aspect again, we want them to keep their eyes on the roads. We got tactical switches. We do have a touch screen, but that touch screen is really more to aid in the convenience of calibration. It's not really used for the driver. And if there's air conditions that pop up on that screen, we do a lot through like different warnings, buzzers, and things like that there too. And also, an air condition isn't necessarily a bad thing. Yeah, we might be detecting a low oil state or because the hose blew and it's leaking hydraulic fluid out, but it might just be too that say the operator jumps in the cab at the start of their shift. They throw their jacket in on the armrest. They turn on the system and the system boots up and it's giving them an error condition. It says joystick off center.
Mm-hmm.
We want to make sure when they turn that truck on, what the system's actually detecting there is that jacket is laying on the joystick.
Oh, okay.
So we make sure that when they turn the truck on, that the wing plow doesn't come down on the car on the side of the truck there. So there's a lot of different things that we're doing there to monitor and give feedback to the drivers. A lot of it, like I said, is buzzers and indicator lights. But the screen is a good operation too, and we do a lot of things with colors. So the joystick, if it's green, it's good. If it's red, it's probably beeping at you. If it's amber, that means that they haven't pushed the button on the top of it yet to activate it. And I hear that from time to time that we've got a lot of buzzers going off in our system, but again, I think it's very important. If you ever hop in a plow truck, anytime I ever get in one, the low air alarm is going off. Why? Because when they start at the truck, they need to let the air charge up because otherwise they don't have brakes. Same thing here. If they're coming up to a bridge deck and they don't have hydraulics to lower that dump box back down, that's a problem. So we make sure that we're indicating this to the driver.
It sounds very elaborate, in terms of the different things. I guess before we started having this conversation, Jeremy, I wasn't even thinking so much about the plow operations, but obviously that's a big piece of the puzzle as you just described it. It sounds like the spreader system is, as you said, set and forget, and then the sensors and the adaptive controls take over from there. But it sounds like there's a lot more feedback and active human control over the angle and the positioning of the plow, whether it's the front plow or the side plows. Am I hearing you right in that regard?
Yeah, there's a lot for the operators to still do.
Yeah.
The driving down the road with the salter portion of it, hopefully it's just set it and forget it unless something comes up. We do have error logs in there, so if something were to happen while they're driving down the road, everything's still functioning. They can come back, look at the error logs and diagnose it later. Maybe it was just a temperature sensor fault. The temperature sensor, we have a sensor that can detect the pavement temperature. Because actually after a certain temperature, below a certain temperature, salt doesn't act the same as it does at higher temperatures.
Mm-hmm.
So they might decide to treat the roads differently based off of some of that feedback. So some of that is manual, but there's a lot of things that is automatic too that we try to do.
Yeah.
So I mentioned the low oil state before. You blew a hydraulic hose, and we've got sensors in there, and we have wiring that will actually immediately shut off the pump or the PTO to help save on the equipment. And then we'll also give the operator a low oil override switch so they can maybe get the function back down and limp home. Or we do have manual overrides too. So we do try to automate things where possible. There's another thing in there too that I always like to talk about. All of our outputs, again, we design around that fail-safe type thing. Mm-hmm. So we have a different power for all of our outputs. If something goes wrong, we don't necessarily rely on software to cut that power. That certainly will happen as well, but we actually design the hardware, the circuit board, the electronics to fail in a safe way. So for example, that I like to use here is with the power going out to those modules, we monitor that power, we control that power. If somebody moved that power wire and they hooked it up hot, we detect that and we will shut off the system and not let them operate anything until that is fixed.
That's great. It sounds like it's there's constant innovation in this space is what it sounds like to me, that you're always adding new capabilities, and that's probably just a symptom of all the data, right? That you're able to collect so much data that you're putting it to good use in these different ways that you've described.
Yeah, there's certainly a lot of new things.
Yeah.
We've seen a lot. I've seen a lot of things over the years with liquids. I never even knew there was such a thing as pre-wetting or direct liquids before my career here, and it's become more popular these days. Driving down the road in Wisconsin, you'll oftentimes see the little lines going down the road. That's the municipality out there pre-treating the road before an event happens.
Yeah, right.
Down south, they sometimes joke about it. They'll actually paint the roads white before it snows as the pre-treating. But yeah, to what you said there too, is the data. We are investing a lot of time and resources into over the air. We've got, with our precise division, we've got AVL, we call it, and that's how we store the data, how we transmit it. We have cellular and GPS built right into our controllers now, and that all that data will get transmitted up to the cloud, and then basically we've got reporting tools that the operators and the municipalities in the end can use to track how much salt they put down,
Mm-hmm.
where the truck has been. We've got route completion reports that they can actually see on a map, green that the truck was there. They can see when the plow blade was actually down,
Yeah.
and when it was back up.
It's a wealth of information as you're describing. It really helps with kind of fleet management, at that level, to know not just where the trucks are, but how efficiently they're performing, how, what pieces of the puzzle need to be repaired or taken into the shop, right? It's feeding all of that information, back to the operations center, if you will. So Jeremy, I'm wondering, if you can speak to it. I mean, is there a lot of opportunity in this space to add more and more of these kinds of systems to more and more trucks, or is the market penetration on this pretty well established already?
There's always room for growth. We do about 4,000 spreader controls a year.
Mm-hmm.
Think about it, that's 4,000 plow trucks being put into service, and we've got a lot of warm climate areas. But it's funny, those trucks actually, I don't even know if there's such a thing as a snowplow graveyard. We see trucks that are 20, 30 years old. This time of year, we're always helping. They're on maybe their third owner of the truck. It typically starts with the municipality, but once they're done with it, it'll go to auction, and then somebody else will buy it, and then a lot of times somebody else from there too.
Yeah.
So these trucks are being used forever. But what we see is the features. I said direct liquids have really been a thing of growth over the last number of years here. We see a lot of new technologies with liquids and a lot of different things municipalities are trying with liquids. We've seen things like directional spinners, where you can actually, they'll angle the spinner chute to try to direct the material to a certain part of the roadway. Or, as I mentioned towards the beginning, tow plows. That's another thing that that's really growing in our industry. We're seeing tow plows that actually they can go in either direction. So what they do is they swing out. They can swing to the left or the right now,
Mm-hmm.
to cover that extra lane, that extra lane width. And all that stuff's important too, because you have one driver and they can now cover more ground with that. So we do see a lot of features. We're not necessarily adding plow trucks every year to the amount of plow trucks out in service necessarily, but we're adding features to these systems.
Right. I'm curious. I mean, again, it's a great example. It's fascinating to learn more about this, and it's a great example of how marrying the control system and the data management to the muscle, if you will, of the hydraulic system just opens up a complete panoply, if you will, of capabilities and opportunities in a space that I don't know most people even think about, except for those guys that are stuck driving those plows through the dark winter nights, if you know what I mean.
Yeah, there's a lot. I still learn every single day. There's
Yeah.
a lot of new things that I see happen every day, and there's just a broad thing of features too. I mentioned before the temperature sensor. We can have the temperature sensor control the amount of material that gets put down on the roadway. Or what we're kind of experimenting with there too is, can we do it with geofencing, with GPS? Can we have it so certain areas the spread rate automatically changes? All those things. There's definitely so much room for new technology in that area.
That's great. Well, maybe we'll invite you back on a future episode and learn more about some of those new opportunities as they develop.
Yeah, I'd love to be back.
Great. All right, well, that is going to wrap things up for this episode of Fluid Power Forum. My thanks to Jeremy Flasch of Force America, who has been my guest on today's show. If you'd like to connect with him, learn more about this application or other capabilities that Force America has, you can contact him via email, and we will put a link to his email address in the show notes for this episode. If you like our podcast, remember to follow us on Twitter. You can find us there at the NFPA. And make sure to share those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. We truly want to hear from you on the kind of topics that you want to hear about on our show. Also, to see the latest fluid power technology and learn from industry experts, make your plans now to attend IFPE, the International Fluid Power Exposition. Our next show will be March 14 through the 18 in 2023 in Las Vegas, Nevada. For more information, visit ifpe.com. Fluid Power Forum is a podcast of the National Fluid Power Association. We are ably produced by Maddie Paris, NFPA's Communications Manager, and I'm your host, Eric Lenke, reminding you to join us next time in the forum.